Hello everyone, we have got a problem in which we have to write the equations of motion of following configuration. Yeah, we have got a particle with charge q, which is positively charged of course, and mass m, having some certain velocity, non-zero velocity in either dimensions, in which a magnetic field is in the plus z direction and electric field is in the plus y direction. Okay, so we assume the component of velocity in x, y, and z axes be u, v, and w respectively. Okay, we define the cyclotron angular frequency, which you have studied in magnetism session, of course, q by m times b. This is a constant. This is why so magnetic force act and particle start moving in helical path, or if given a velocity earlier. Okay, again a very special speed which I am not going to define for for uh, for this time. It's a surprise for you, although you know E over B is converges to some speed, and we define it be a capital V. Let this be a capital V. We are not going to interfere with this. Not a small v. No, capital V is the bigger one, and not it is a constant right here, because we assume the magnetic field and electric field are constants. Okay, non-changing. We start by Newton's second law. By Newton's second law, sum of forces in x direction would be equal to mass times acceleration in x direction. Acceleration in x direction can be written as derivative of u, time derivative of u. Dot represent the time derivative. Okay, we are talking of force in x direction, so applying right hand rule, this is x direction. It is coming out of place, so my thumb point in the x direction. This is the velocity. Index finger tells the velocity and middle finger tells the magnetic field. So why not just orient and crunch up our fingers to get the resulting orientation as demanded in the system. Okay, force is in the right place, also the magnetic field is in the right place, that is z direction. So my index finger is tending towards the y direction, and component of velocity in y is v. Okay, I hope that's not going to interfere you all so much, not in negative sense, of course. Crunch up some fingers and you will get your required answers. Of course, physics is like that. The very famous thing about this problem is it delves deeper into the nature how it works. You have seen bicycle ridings. It similarly follows that path. We'll show how. Okay, the sum of forces in y direction is going to be a trickier part, so have concentration on this part. Okay, q times e, because in y direction there would be two forces due to E and due to magnetic force, Fe and Fb. Okay, we have written Fb. Now the time come for Fb. So force we are considering in y direction, so my thumb must point in y. Okay, y is force is in this direction. Now these two fingers are still not oriented properly. This is magnetic field. Middle fingers represent the magnetic field, so it must represent here. Okay, as you can see, this force is in the right of me, and now the velocity part goes in negative of x direction, that is right into the page, minus x. Okay, q, the component of velocity in x-axis, b, u and b. Okay, v dot. Okay, now again let me give some more space. Okay, fz m times w. Let's not forget cyclotron angular frequency is also there, so we must not forget w and omega. So we must tend to recognize them properly. Okay, we get there is no force in the z direction. Sum of all forces in z direction is 0. Okay, m times time derivative of w is 0. Okay, from all these we get some good stuffs. Okay, q v b times m. Okay, v dot can be written as q e by m minus q u b by m. Okay, let's box it here, so it will increase your attention towards it. This is going to be 0. Mass is not 0 here. Of course, this is not a photon. So u dot can be represented as we have already mentioned, we have defined q by m times v is omega v. Let's box it here. This is a great thing we have covering. Okay, v dot can be represented. Let's assume there is a b and b. Q by m times b is going to be omega, and e by b is going to be capital V. Okay, capital V. Q by m times b is omega and u. Okay, let's reverse it a bit. Let's take common minus of omega, u minus capital V. Let's not forget this is capital V, and other thing or this thing is small v. Okay, let's box it here. Let me give some more space. Okay, assuming x b u minus w. Oh, sorry, this is capital V. Okay, we have defined a term where one part is ever changing, it is not constant, and it is constant. So unintentionally we take either derivative of this function. So u dot, we get a u dot because this gets to 0 because this is a constant, and taking time derivative we get u dot, we get omega times v. Okay, let's take another derivative of x function, second derivative of x, time derivative. this is a constant, so we take out of constant and we start putting v dot. Yeah, you can see omega times v dot is nothing but minus of omega square. What we have seen is u by v, u by v, capital V, of course. U by v is the same thing, x. Okay guys, this is going to be a crucial part. We have seen in simple harmonic motion, the second derivative is this a constant and some that function. Okay, it is an it is a SHM, simple harmonic motion. So we can give a general solution of this function. Alright, so we can write the general solution of this function x. Let this be a constant, a sine of omega t plus alpha. This has become a very general solution, and this is going to sort out many things. What I mean by sorting out the things is, we have seen here x equals to small u minus capital V. Okay, small u is the component of speed in x direction, so why not we just write u equals to a sine of omega t plus alpha plus capital V. We have got something amazing, and u is nothing but time derivative of x coordinate of a particle. So what are we going to do just here? Just differentiate and integrate to find the u dot and also x dot dot. I'm just very excited. Let me show you how. So x dot dot or u dot can be written as a cos omega t plus alpha times omega. This is going to get cancelled. Okay, again u dot or x dot dot a omega cos omega t plus alpha. Integrate this equation. Let's work right here. Integrate this equation to find x dot can be represented dx by dt. So why not just, yeah, this is the same thing, but to get x we are going to do this function integration. I have not shown you how to differentiate, but it is my duty to do the required integration to get the required solution of this problem. Okay, let me give some more space. Okay, minus a by omega. Yeah, this you can see differentiating this is not nicer, but you must do it. V times t, we get another variable, and we must add some arbitrary constant also. We have got x function. So similarly or what, we can find the y component, y everything related to y, of course. So we have got v dot minus omega times u minus v. Okay, y dot dot can be written as v dot, and v dot we have here minus of omega x. Okay, x can be written as minus of, right here, sine omega t plus alpha. Okay, let's get this right. Okay, some more space. Now what are we going to do is to differentiate all these. So a omega upon omega minus times minus gets plus omega t plus alpha, and a funky funny arbitrary constant. Let's put this f. I'm not good at choosing integration constant, so this gets cancelled out. We have got y dot. So why not get y, function of y? That's what we are aiming for. We have got x, we are going to have y. Okay, so a by omega sine, this gets sine omega t plus alpha Okay, where we are, okay, f times t. Let's choose this another z. Okay, I hope that's not okay. M, why not m? Okay, I'm good at choosing constant. Okay, adding some more space for getting z, equation of z. Okay, we know z dot dot is 0, so integrating this is going to be easy one. Integrating this into z dot, oh, z naught, this is w, oh sorry, this is w dot and z dot dot. Okay, this is quite understandable. Okay, z dot or w is going to be constant. Let's say omega naught, okay, in omega this is w naught. I am doing the same mistake, just to let you know, don't do this. W naught is something at initial time. At t equals to 0, the speed, the vz. I hope you understand the terms of vz. Okay guys, we have derived the equations of motion x and y, and we have also derived z dot or w, which we have got w naught. It is a constant, arbitrary constant. which we have explained. Okay, Z can be represented as this. Taking the differentiation, we get the same thing. Not W naught, it is going to be a Z naught. Yeah. Okay, we have got all things sorted out. So let's assume A cos alpha B capital C. This is for the sake of convenience, and A sin alpha capital S. Okay, again A cos alpha, cos, we are expanding the cos, okay, compound of angles. A cos alpha is capital C cos omega t minus sin omega t. Okay, Vt plus d. Okay, 1 by omega is A sin of omega t and cos alpha, A cos alpha. So capital C sin omega t plus cos of omega t, cos of omega t sin of alpha, A sin of alpha, A sin alpha capital S. Okay, Ft plus M. Okay, Z, it is all the same. Okay, this is somewhat we are going to get, and this is not pretty awesome thing which we have supposed. Yeah, but of course if we assume our particle is at origin at the point of consideration, so x y equals to z at time equals to 0, what we mean is uh, the particle does not get ready with some initial velocity. Actually, the electric field is already giving it some directional forces in y direction. So u and v must also be 0. Okay, putting these all initial conditions, we see that A cos alpha gets 0 and A sin of alpha becomes minus capital V. We also observe further okay, the equations finally x equals to minus V by omega and y equals to cos of omega t. I want to make sure that this kind of motion is followed is called cycloidal motion. And you can start putting these variables in Desmos calculator, graph calculator, which I have put the link in the description to rock it up.